We are going to be looking at Introduction to Probability, in particular two first modules, the Introduction to Probability Concepts and Notations, and the Law of Large Numbers. So the first module that a lot of you have already taken a look at, we're going to go to the content portion of it, and I'm going to very quickly go over some of the things that you need to submit. So again, you're going to go through it, and it talks about probability, experimental versus theoretical. So theoretical is what should happen, and experimental is what does happen. So you can see some of the solutions here. Go to the Games Fair, you enter it, and you can, if you want to, go to your portfolio that I said earlier. That's an option for you to submit some evidence of your learning, and I'll show you that later on in the video how to do that. And just to kind of summarize what I'm looking for is at the very top here, we can use A to represent set A. So A is 6 because we want the dice to land on the 6 face. And then we talk about n bracket A bracket equals 1. So the reason we have this is because there's only one possible way for us to roll a 6 on a die. So there's 6 possible solutions. There's only one solution that actually has 6, because that's what we want to happen. And we use S equals 1, 2, 3, 4, 5, 6 because these are all the possible solutions. This is everything possible. So in this case, n bracket S bracket equals 6. This means that there's 6 possible solutions. We write the solutions out up here, and then we add them all up, and in total there's 6 possible solutions. So when we write it, we should write it like this. This is the formula for it down here, and eventually we get n bracket A. This is the probability of set A occurring, and then this is out of the possible outcomes. So there's 6 possible outcomes, and we want the number 6 to be rolled. So we used to be able to just put 1 out of 6, but now we're working towards writing it like this in the drop box, where we write what we want, the possible solutions, the number of ways we can get the one that we want, and the number of possible solutions, and we finish off by writing it as such. That's an example you can go through on your own. And then eventually we get to something called the indirect method. So the indirect method is when you do the complement of the event. So instead of writing A, we write A primed, or in this case, A complement. Some other websites refer to it as AC for the complement. So the A complement is anything that is the opposite of what you want to occur. So we want 6 to occur, but like rolling 6, but we have 1, 2, 3, 4, 5 is the complement of that. Therefore, the chances of us, the probability of us rolling the complement is 5 out of 6. So for us to write it mathematically, we can write it as such right here, where we have n bracket A bracket equals n bracket S bracket minus n bracket A complement. So basically all the solutions, right, subtract the complement, and we would get the number of times our 6 we rolled. So what you need to do in the Dropbox is you need to take a look at this caterpillar and come up with a probability scenario and solve for it. So when you watch this video, it's very specific. So some of you might look at it and say, okay, with the caterpillar, it can either go middle, it can go left, or it can go right. Some people are even specific and saying 45 degrees right. So that would be 3 options. However, if you look very closely, you can see that there's different arrows. So this might be, I think this would be to the right. This would be to the right as well. Left, left, straight, straight. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible vertebrae of the caterpillar. And whichever one lights up, that will tell the direction of where the caterpillar goes. So let's take a look here. So it's been lit up, and eventually here it looks like, oh, this one's flashing, so it's going straight. So it had a 1 in 8 chance of going straight, or however many straights there are. So there might be 1, 2, 3. So the probability might be a little bit different. I can't give you the exact answer, but that might be a hint as towards how to come up with a solution. Again, this one's very similar, where you have your arrows and it predicts where the caterpillar will go. So in this case, this one, it's flashing. So it went to the right, and because it was flashing right, that's why it went that direction. So you need to, down here, come up with a probability question, which I may have already alluded to one that you could use, and communicate your ideas using correct notation learned in this activity, and pose another and solve another question related to the indirect method. So again, up here, this is the correct method that I'm looking for when you do it, making sure that you do it in this format. And not only that, you also label A equals, so maybe left, middle, right, or path 1, path 2, path 3, and then you write down the possible n bracket A and n bracket S, and then you finally finish it off with putting it into this formula and putting it into percents. You would do this, and then you'd also do it as the indirect method for the complement of what the other possible solutions were. So if it went, for example, if you did this one where it went right, you do the complement of it, the indirect method of what other options, so straight or left, for example. So that is what I'm looking for the Dropbox for Introduction to Probability and Concepts and Notations. Now, very quickly, well, not very quickly, but I'll try as quick as I can. We're going to go to the law of large numbers. And basically what the law of large numbers states that we're trying to learn here is that the more often you do something, the more accurate the theoretical probability will be. So, for example, if you were to shoot 10 free throws in basketball, you might successfully make 8 of those shots, and you might have got lucky. And so, if you were to maybe shoot 100 free throws, or maybe 1,000 free throws, that would be more accurate representation of your actual shooting percentage, and you might only get, let's say, 70% or 72% of those free throws correctly in. So that's kind of in a nutshell what the law of large numbers is. Now, you're going to go through this again, take a look at it, and go through the activities. And it says record your thinking. So it says reflect on a strategy as it relates to your theoretical probability. Consider what you've learned in this activity. And it says go to your profile. So some of you are using this, some of you are not quite yet. Again, my first video I said don't worry about it, but it is important for you to be able to use. So let's go to portfolio. And the reason I like using your portfolio is because this way it gives me an option. Let's say if you do really poorly on a test or an assignment, I can reflect back and take a look at your portfolio to see what you've submitted. So I've already asked Caitlin here for permission, and she's willing to share some of her portfolio here. So this was, I believe, the card flip experiment. Thank you. And then she had to go to her portfolio, and it just says reflect on the following question. It is always easy to find the probability of winning. Use some specific examples to justify your answer. So Caitlin, thank you for letting us see your answer. I gave you a little bit of feedback over here on your evidence, and this way, if when it comes to the assignment, if Caitlin doesn't do so hot on the law of large numbers, I can reflect back and say, oh, look, this is some evidence that she did understand some of it. Maybe she just missed a part of the assignment, and I can justify maybe giving Caitlin a different mark or a little bit higher mark. So submitting evidence to the portfolio, yes, it is important. Are you getting marked on it? Not directly, but indirectly, yes, you are, because it's an opportunity for you to show that you're doing the work and that you can reflect back on some of the evidence that you have throughout the modules. So I hope that this was helpful for the caterpillar problem and some of the law of large numbers. Now, I know there is a lot of go to your portfolio questions. So what I would recommend is to put it into a Microsoft Word document. And after you have it in the Microsoft Word document, then submit one large sheet or document into the evidence. So you're not putting multiple sheets in and it gets overwhelming. That would also help me out on my behalf. I'd appreciate that. And I think that is it for the content for the law of large numbers. I will be sending another video tomorrow talking about working with mutually and non-mutually exclusive events. And this and compound events and dependency are due Wednesday. So if you get these two done by Friday, you're on pace. So I hope you enjoyed the snow day for some of you who had it, and more to come.